Ever wondered how neural networks are transforming our world? In the vast, ever-evolving landscape of technology, one concept that's making waves is neural networks. These are not just some lofty, futuristic ideas, but systems that are here, now, working behind the scenes, touching various aspects of our lives. So what exactly are neural networks? At their core, neural networks are designed to mimic the human brain. They replicate the way we think, the way we learn, and the way we make decisions. This might sound like science fiction, but it's science fact. By harnessing the power of advanced algorithms and computational power, neural networks can identify complex patterns, interpret them, and make informed decisions. Imagine a toddler learning to recognize objects around them. They see a round object, they're told it's a ball, and over time they learn to identify all kinds of balls. Big, small, red, blue. This is how neural networks learn, by being fed vast amounts of data and learning from it, just like a human brain. Neural networks are not limited to one field or industry, they are everywhere. In the realm of medicine, they're being used to diagnose diseases, sometimes even before symptoms become apparent. In the automotive industry, neural networks are the bedrock of self-driving technology, helping cars navigate complex environments safely. In the finance sector, they're used to predict market trends, helping businesses stay ahead of the curve. These are just a few examples. Neural networks are revolutionizing countless other sectors, from entertainment to agriculture, from manufacturing to retail. They're helping us process enormous amounts of data, perform calculations in real time, and make our world smarter, more efficient, and more connected. But how do these neural networks actually work? Let's dive in. Neural networks at their core are like the human brain. They operate on the principle of learning through experience, processing data via layers of artificial neurons, much like how our brain processes information using biological neurons. To break it down, let's imagine a child learning to differentiate between cats and dogs. The child views several pictures of both animals, and each time they guess which animal it is. Sometimes they're right, and sometimes they're wrong. When they're wrong, they adjust their understanding based on the new information. Over time, this trial and error process helps the child accurately identify cats and dogs. This is essentially how a neural network functions. The artificial neurons in the network are provided with input data, to which they apply different weights. These weights are nothing but the importance assigned to each input. If the network predicts the output correctly, well and good. If not, it adjusts these weights based on the error, just like the child adjusts their understanding. This process happens across multiple layers of neurons within the network. The first layer, called the input layer, receives the raw data. This data is then processed through one or more hidden layers where the magic of learning happens. The final layer, aptly named the output layer, delivers the final result. Now, you might wonder, how does the network know if it's made an error? Well, during the training phase, the network is provided with both the input data and the correct output. The network's output is compared with the correct output, and the difference between them is the error. This error is then propagated backward through the network, adjusting the weights of the neurons. This process, known as backpropagation, is repeated several times, allowing the network to learn from its mistakes and improve its performance. So you see, it's all about learning from errors, much like we humans do. The beauty of neural networks lies in their ability to adapt and learn, transforming raw data into meaningful insights, one layer at a time. Now that we know what neural networks are and how they work, let's explore where they are used. Dive into the field of medicine and you'll find neural networks playing a vital role. They aid in diagnosing diseases even before the symptoms become apparent. For instance, they can analyze medical images and detect anomalies like tumors or fractures, often with a higher degree of accuracy than the human eye. Neural networks can also predict the likelihood of disease progression based on a patient's medical history, helping doctors devise effective treatment plans. Now shift gears and look at the automotive industry. The concept of self-driving cars isn't science fiction anymore, and neural networks are at the heart of this revolution. They help these vehicles understand their surroundings, recognize traffic signs, and make decisions in real time. This technology not only makes driving safer but also more efficient, reducing the chances of traffic congestion and accidents. Next, let's talk numbers. In the financial sector, neural networks are used to forecast market trends. They analyze historical data, identify patterns, and predict future values. Businesses can then make informed decisions about investments, pricing strategies, and more. Similarly, in the retail sector, neural networks can predict consumer behavior and trends, enabling businesses to tailor their offerings and marketing strategies accordingly. But it doesn't stop there. From enhancing the accuracy of weather forecasts to powering recommendation systems on your favorite streaming platforms, neural networks are everywhere. They're even used in cybersecurity, identifying suspicious activities and detecting potential threats to keep our digital world safe. And remember, this is just the tip of the iceberg. With ongoing research and advancements in technology, the applications of neural networks are bound to expand even further, permeating every corner of our lives. As you can see, neural networks have a wide range of applications, transforming the way we live and work. But what does this mean for us in our future? Neural networks, with their capacity to model complex patterns and make automatic decisions, are leaving an indelible mark on our society. They're not just some high-tech jargon or abstract concept. They're changing the way we live, work, and interact with the world. Take data processing, for instance. We're living in an era of information overload where every click, swipe, and keystroke generates data. Processing this vast sea of information would be an insurmountable task for humans. But for neural networks, it's all in a day's work. They can analyze massive amounts of data, identify patterns, and make decisions in real time. This is the engine driving our modern technological progress, making everything from personalized shopping suggestions to real-time traffic predictions possible. But it's not all roses. The rise of neural networks also brings potential challenges. One of the most immediate concerns is job displacement. As neural networks become more proficient, they're likely to take over tasks traditionally performed by humans. This could lead to job losses in some sectors, even as it creates new opportunities in others. And then there's the question of privacy. With neural networks capable of processing immense amounts of data, how do we ensure our personal information stays safe? It's a concern that's only going to grow as neural networks become more integrated into our daily lives. There's also the risk of bias. Neural networks learn from the data they're fed. If that data contains biases, the neural network could inadvertently perpetuate them, leading to unfair outcomes. Despite these challenges, there's no denying the transformative potential of neural networks. They're already helping us solve complex problems, make more informed decisions, and improve our quality of life. It's clear that neural networks hold immense potential, but they also pose certain challenges that we need to be aware of. As we continue to navigate this brave new world of artificial intelligence, it's essential that we strike a balance, leveraging the benefits of neural networks while also addressing the potential pitfalls. So there you have it, a brief overview of neural networks. This intricate web of interconnected nodes, or neurons if you will, is designed to mimic the human brain's pattern recognition abilities. Neural networks learn from experience just like we do. They absorb vast amounts of data, find patterns, make connections, and then use this knowledge to make decisions. It's a fascinating blend of biology and technology, isn't it? We've also delved into how these networks function. Remember the concept of layers? The input layer receives the data, the hidden layers process it, and the output layer delivers the final verdict. Each neuron is like a tiny, specialized worker, contributing its small but significant part to the grand scheme of things. It's a beautiful example of teamwork and synergy. The applications of neural networks are as diverse as they are impressive. In medicine, they help diagnose diseases with incredible accuracy. In the automotive industry, they power the autopilots of self-driving cars. In finance, they forecast trends and help investors make wise decisions. The possibilities are seemingly endless. The impact of neural networks cannot be overstated. They're transforming our world, making it more efficient and intelligent. They're helping us solve complex problems and revealing insights that were previously beyond our reach. The best part? We're only scratching the surface. The potential of neural networks is immense and we've yet to uncover all its secrets. If this intrigues you, I encourage you to delve deeper.